Hi guys, this is group 4.
And this is Rosie Coleman.
I'm Stephanie Reynoso.
Sylvia Madrana.
Denise Guevara.
And today we are going to talk to you guys about the eye, specifically about the blind spot. Now, what the blind spot is, it's the part of the retina that does not contain any receptors. Now, by receptors, I mean the part of the eye that doesn't detect any light. Now, the retina is it's a layer located in the back of your eye. Now, when images fall in that particular area, those images cannot be seen since they have landed on the blind spot. Now, I'm going to show you guys a few images here that describe what I just mentioned to you guys. So basically here, this is the eye that we all tend to see. This portion here, where we're looking at this here, that is the retina there, and this is the blind spot. Now, when items do fall, or any thing that you see that falls under that particular area, that's what we call the blind spot. Now, Stephanie will go ahead and further inform you guys in regards to some research she conducted in regards to this matter.
So the study that I found was by Lang Lo and Jing Chen, and they conducted this study from the Department of Psychology at Grand Valley State University in Michigan. And this study examines attention and blind spot phenomenology. Wow, what is phenomenology, you ask? That's the study on perception and what is understood. So it can get very philosophical, but what it is, it's your personal way of experiencing, or the way that you see your experience. So the researchers began exploring this issue, the issue of the blind spot, by conducting experiments. And what they did was they took 18 participants and studied their eyes individually, and they presented them with a broken bar and a red disc flashing. Now the red disc wasn't visible, they saw it on their blind spot, and so the 18 participants weren't aware of that the bars were broken. They actually saw them as continuous, of different lengths and widths. These The bar was broken, but it appeared continuous until the participant tried to hone in, or they tried to confine their attention around the blind spot. Now, when they did try to scrutinize it, that's when they saw it to be broken. The study concluded that visual filling in at the blind spot, and that's the process of making your brain making up what you didn't actually see. So it concluded that visual filling in at the bar was A, misleading, and B, easier for your brain to do if attention is not confined on the blind spot. Now I have Rosie here, and she'll demonstrate to you a test, how you can test your blind spot.
Hello. So as she mentioned, everyone has a blind spot. So now what we're going to do is we're going to go ahead and check for yours. Here's a fun test that you can take. So first, what you want to do is sit upright in front of your computer and stare at the middle of the sheet in between the dot and the cross. What you will do then is cover your left eye and stare with your right eye at the dot. Now slowly move towards the computer screen while still staring at the cross. At some point at around 10 or 14 inches from the computer screen, the black circle will disappear, and the area where the black circle was will now be white. This is your blind spot. If you move closer to the screen or farther away, the circle will appear and disappear at a specific distance. You can also try this with your other eye, and the same thing will occur. So now you know where your blind spot is. Now Denise will conclude.
Hello, so we hope you enjoyed our presentation, and now remember, don't trust your eyes and no one else's. Thank you for your time.